Hello and welcome to Dr. D.Y. Patil Vidyapit Center for Online Learning. This is Unit 9 of Performing Analytics with Python, that is Analytics Part 2. So, before we proceed to the session, let us look at the agenda for this session. In this session, I am going to cover about predictive analysis, logistic regression, decision trees and support vector machine, that is SVM. So, let us start with the session. So, what is predictive analysis? A predictive analysis is the process of using historical data, statistical models and machine learning algorithms in order to make predictions to extract the insights about the future outcomes or the events. So, it helps the organization to gain insights and make the informed decisions and take the proactive action. So, when I say a predictive analytics, it is a process or it is rather an analytic process in which we are using the historical data, we are using the statistical methods and machine learning algorithms, and by using this we are making the predictions about the future outcomes, about the future events. This will help the organization or the managers to gain the insights and make the informed decisions, and so that they can take proactive decisions. So, let us understand the process of the overall predictive analytics, what are the steps of this predictive analysis. So, first step is the problem definition. So, in this we are clearly defining the business problem, what is the target objective or what is the objective that the predictive analytics is going to solve or it is going to address. So, here we are identifying the target variable to be predicted. So, the first step is to define the problem. So, clearly defining the problem is very important, so that we can address, we can solve the correct problem, otherwise we would waste time and money in solving the wrong problem. So, here the first step is to identify or to clearly define the problem that the predictive analytics is going to address, that is identifying the target variable to be predicted. So, this in the second step we are collecting the data, that is data collection and preparation. So, here I am collecting the data from various sources, it can be from web resource, it can be from journals, it can be from magazines as well. So, gathering the relevant information, gathering the relevant data rather from various sources and cleaning them and pre-process the data, that is handling the missing values, handling the anomalies and transforming the variables as needed, that is reshaping the data is also done in this second step, that is data collection and preparation. So, the second step we are collecting the data from different sources and we are cleaning the data, we are preparing the data, we are making the data ready for the preparation. So, cleaning involves identifying the anomalies, identifying the missing values, and here we are also reshaping the data, means what, we are transforming the variables as and when required. So, this is the second step, that is to collect the relevant data from different sources. The third step is the exploratory data analysis, that we all know as EDA. So, in EDA, that is exploring, we are exploring the data, identifying the patterns and the relationship and the outliers, so that we can gain the insights which will guide the modeling process. So, in EDA we are exploring the different parts of the data, we are identifying the patterns, we are identifying the relationship and the outliers, so that we gain the insights which will guide further in the analytics process. So, that is called as exploratory data analysis, EDA. The next step is feature engineering. So, in feature engineering we are creating new features or we are transforming the existing features to enhance the predictive power of the data. So, here we are standardizing the data, here we are reshaping the data, here we are transforming the categorical data to a numerical data. So, that is called as feature engineering. Here we are creating new features, here we are adding new additional features, so that the analysis process can be and more enhanced, or we can here adding more features, like say for example reshaping the values, reshaping the variables, for example transforming the categorical values to a numerical one. So, that is called as feature engineering, where we are adding new features or we are transforming the existing features, like transforming the categorical data to numerical data to enhance the overall predictive power of the model or of the data. That is feature engineering. In the next step is a model selection. So, in this we are selecting the appropriate predictive model which is based on the problem. The model can be regression, the model can be a classification model, or it can be a time series. So, based on the problem and on its characteristics, we are selecting a particular model. It could be a regression model, it could be a classification model, or it could be a time series model. It is totally based on what problem that we are addressing and what are the characteristics of that problem. So, based on that we have to select an appropriate model. So, this is model selection process. After selecting the model, the next step is model training. So, here once we are selecting the model, now we are training the model. How we can train? By splitting the data into training and testing sets. So, here we are training the model by using the training data, that is fit the selected models on the training data and tune their parameters to optimize the performance. So, in model training we are training the model with the trained data. The next step is model evaluation. So, once the model is been trained, now I need to evaluate the performance of the model. So, in order to measure the performance of the model, there are many metrics like accuracy, precision, recall and RMSE. So, these are the metrics by which I can measure the performance of the selected model, how well the model has predicted. So, this is model evaluation, which will evaluate the performance of the models using the suitable metrics. The metrics can be accuracy, precision, recall or RMSE, and we select the best performing model. So, here on the basis of evaluation of the model, we select the best performing model. So, this is called as model evaluation, where we are evaluating the performance of the model by using different metrics. The next step, once the model has been evaluated, once the model has been chosen, the best model has been selected, now the next step is the model deployment. So, here we are deploying the selected model to make the predictions on a new or unseen data. That is, now here I am testing my model on unseen data or entirely a new data, so that I can find how well the model has performed, what is the accuracy level of my model. So, here once the model has been deployed, I can monitor the model's performance and I can update as and when needed. Means what? I can maintain that model as and when required. The next step is interpretation and action. So, here we are interpreting the results, the output of the model, that is interpret the predictions, extract the insights and take the appropriate actions or make the decisions based on the results. So, whatever interpretation has been given by the model, whatever insights that has been provided by the model, here we are taking the decisions based on that specific results. So, that is called as interpretation and action. Means what? Here we are interpreting the results, the insights, the extracts that the model has presented, so that we can take the decisions based on the results that is been provided by this particular model that we have deployed. So, now let us understand what could be the predictive modeling techniques. So, there are different modeling techniques which are used for predicting modeling. So, for example, regression. Regression is basically used for predicting the continuous numerical values. So, if you are predicting continuous numerical values, then your model, your predictive model should be regression. Again, here we have different versions of that regression, that it could be linear regression, it could be polynomial regression, or it could be a decision tree, or regressions are common techniques, as the regressions are common techniques. So, these are the different forms of regression. It could be linear regression, it could be polynomial regression, or it could be decision trees as well. So, these are the some of the predictive modeling techniques that we can use in case that I am predicting the numerical values. The next predictive modeling technique is classification. Basically, classification is used for predicting the categorical outcomes. So, if you want to predict the categorical outcome, then we go for the classification. Say for example, email analysis, whether email is ham or it is a spam. For that I can use the classification modeling technique. So, wherever we are predicting the categorical outcome, so in that case we can use the classification model. So, in classification model, basically we are assigning the data points to predefined classes. In case of logistic regression, decision trees, random forest and support vector machines are commonly used. So, in classification as well, classification is basically used for predicting the categorical outcome. Like I said that if I want to categorize whether an email is spam or not spam, I can use classification modeling technique. Again, if I have to categorize the data, that is which into say negative, positive or neutral, that is sentiment analysis. So, I can use classification model. So, classification is basically used for predicting the categorical outcome. So, in that we are assigning the data points to the predefined classes. So, this is about classification, which can be used for predicting modeling as a predicting modeling technique. The next technique is a time series. So, basically I have said that for predictive modeling techniques we have classification, we have regression and again we have the time series. Based on the problem that we are addressing and its characteristics, we can select any particular model. So, the third modeling technique is time series, which is used for predicting the future values based on the patterns and trends observed over a period of time, that is observed in historical time or time series data. For example, ARIMA, exponential smoothing and recurrent neural networks are popular methods. So, in case of time series, these are the methods that I can use, that is ARIMA, exponential smoothing, recurrent neural network, they are being used in time series analysis. So, basically time series is used for predicting the future events by analyzing the time series data which is collected over a period of time. So, this is about the time series analysis predictive analytics technique. The next technique which can be used for predictive modeling technique is ensemble methods, which will combine the multiple models to improve the prediction accuracy and robustness. Like say bagging, boosting and stacking techniques are commonly employed. So, in case of ensemble methods, which is basically combine the multiple models to improve the prediction accuracy and robustness. So, in this ensemble methods we have bagging, boosting, stacking. These are the commonly used techniques for ensemble methods. So, now let us understand the model evaluation and validation, how it is been done. So, first we split the data into training and testing to evaluate the model's performance on unseen data, and we use the appropriate evaluation metrics based on the problem that we are addressing. The metrics can be accuracy, precision, recall, F1 score, AUC-ROC. So, these are the metrics on which I can evaluate the performance of the model. Again, I can use one of the model, that is cross validation techniques. For example, k-fold cross validation can be used to assess the model's performance on multiple train test splits. Now, let us understand the interpretation and communication, that is one of the stage of predictive analytics. So, in interpret, we are interpreting the predictions and understanding the factors that driving the predictions. We communicate the results and insights to the stakeholders in a clear and actionable manner by using various visualization techniques, reports or dashboards as well. Predictive analytics allows the organization to use the historical data and advanced modeling techniques, that is machine learning, to make the informed predictions, anticipate the future events and make the proactive decisions or proactive trends. And by following a structured predictive analytic process and selecting the appropriate modeling technique, analysts can build accurate and reliable predictive model to drive the business outcomes. So, now let us understand the logistic regression. So, basically logistic regression is a popular statistical model which is used for binary classification problems. So, if you are dealing with a binary classification problems, then I will go for using the logistic regression. So, it predicts the probability of an event or outcome belonging to a particular class based on the input variables. That is binary classification, which involves predicting one of the two possible classes or the outcomes. For example, predicting whether a customer will churn or not, whether an email is a spam or not, or whether a patient has a disease or not. So, these are the problems of binary classification. So, in order to address these problems, we can use the logistic regression. Logistic regression models the relationship between the input variables, that is the predictors, and the log odds of the binary outcomes. The log odds are the transformed using the logistic function, also called as the sigmoid function, to obtain the predicted probabilities. The logistic regression equation, let us understand the equation of the logistic regression model, which is given as P of y is equal to 1 given x is equal to 1 divided by 1 plus e raised to minus z. So, this is the logistic regression equation model, where P of y is equal to 1 given the x is the probability of the positive outcome, whereas x represents the input variables and the z is the linear combination of the input variable and their corresponding coefficient. So, now let us understand the assumptions of logistic regression. The first assumption is the linearity. There should be a linear relationship between the input variables and the log odds of the outcome. So, there should be linear relationship between the input values and the log odds of the outcomes. The second assumption is independence of errors, that is, the observations should be independent of each other. The next assumption is no multicollinearity, means the input variables should not be highly correlated with each other. The next assumption is large sample size, it requires large sample size. So, if your sample size is large, then the logistic regression performs well, it gives you more accurate results. Now, let us understand the model training and parameter estimation in logistic regression. Logistic regression estimates the coefficients, that is the weights that maximize the likelihood of observing the given data. Maximum likelihood estimation, that is MLE, or the optimization algorithms like the gradient descent are commonly used for parameter estimation. Now, let us understand the model evaluation in logistic regression. Evaluation metrics for logistic regression includes accuracy, precision, recall, F1 score and area under the receiver operating characteristics, that is ROC curve. So, these are the metrics which are used to evaluate the performance of the logistic regression model. Next, I can evaluate by using the confusion matrix and ROC curve as well. So, confusion matrix and ROC curve can be used for visualizing and analyzing the model's performance. Now, let us understand the multi-class logistic regression. The multi-class logistic regression extends the logistic regression to handle the problem with more than two classes. So, if you want to handle with more than two classes, then we have to go for multi-class logistic regression model. The common approaches includes one versus rest, that is one versus all, and multinomial logistic regression. Now, let us understand the regularization in logistic regression, that is regularization technique like L1 regularization, that is lasso, and L2 regularization, that is ridge, can be used to prevent the overfitting and improve the model's generalization. Now, let us understand the applications of logistic regression, where I can use the logistic regression. Logistic regression is widely used in various domains, including the healthcare, including finance, marketing and social sciences as well. It can also be used for customer churn predictions, fraud detection, risk assessment, sentiment analysis and much more. Now, let us come down to decision trees. What is decision tree? A decision trees are versatile and interpretable machine learning models used for both classification as well as for regression. Classification is used for categorizing and regression is used for predicting the numerical values. So, a decision tree can be used for both the purpose, that is classification as well as for regression task as well. So, they learn the simple decision rules from the data to make the predictions and create the intuitive decision boundaries. Now, let us understand the basic structure of a decision tree. A decision tree consists of nodes, branches and leaves. The nodes represent decision points or features, whereas the branches represents the possible outcomes or paths, and the leaves actually represent the final predictions or the decisions. So, this is how a decision tree structure is been formed. Now, let us understand the basic structure of the decision tree by splitting the criteria. So, splitting criteria determines how the decision tree splits the data at each node. That is, common splitting criteria includes Gini impurity and entropy for classification tasks, and mean squared error or mean absolute error for regression task as well. Now, how to build a decision tree or how a decision tree is been built? The decision tree building process involves recursively splitting the data based on the selected splitting criteria until a stopping criteria is encountered or is met. The stopping criteria can be based on the maximum depth of the tree or the minimum number of samples required to split a node or other measures. Now, how to handle the categorical and numerical features in decision trees? Decision trees can handle both categorical as well as numerical features values as well. Categorical features are split based on the distinct categories, while the numerical values, numerical features are split based on the thresholds. Now, how to prune, how the pruning process occurred in decision trees? Pruning is a technique basically to prevent overfitting of the model. That is, pruning is a technique to prevent the overfitting in decision trees, which involves removing or collapsing the nodes or branches that do not contribute significantly to the model's predictive power. So, here we are pruning, we are removing the nodes or the branches that do not contribute significantly much to the model's predictive power. Now, let us understand the decision tree algorithm. Popular decision trees algorithms includes CART, that is classification and regression trees, ID3, that is iterative dichotomizer 3, and C4.5. So, these are the popular decision tree algorithms which we can be used. CART is commonly used and supports both classification and as well as regression tasks as well. Now, let us understand the interpretability and visualization in decision trees, how it has been done. Decision trees are highly interpretable models as they can be easily visualized and it can be understood. The decision tree structure can be visualized using the diagrams, using the graphs which shows the splitting criteria and the decision paths. Now, let us understand the ensemble and decision trees. The decision trees can be combined into ensemble to improve the predictive accuracy and robustness of the decision tree model. Random forest and gradient descent, gradient boosted trees, that is XGBoost, light GBM are the popular ensemble methods which are based on the decision trees. Now, what are the advantages and limitations of these decision trees? The advantages of decision trees includes interpretability, handling both numerical as well as categorical features and handling missing values as well. Now, what are the limitations? Limitations includes overfitting, instability with small changes in the data and sensitivity to imbalanced class distributions. These are the limitations of decision trees. Decision trees are widely used in various domains for their interpretability and ability to handle different types of data, that is numerical as well as categorical, understanding the construction process, splitting the criteria and pruning the techniques and visualization methods of decision trees can help in effectively applying and interpreting these models, that is decision trees. Now, let us come down to SVM, that is support vector machine. The support vector machine is a powerful supervised learning algorithm used for classification and regression tasks as well. So, the support vector machine is used for both the purpose, that is for classification and for regression also it can be used, which will aim to find an optimal hyperplane that maximally separates the data points of different classes. Let us understand the linear SVM, that is linear support vector machine. Linear support vector machine separates classes by finding a hyperplane with the maximum margin, where the margin is the distance between the hyperplane and the nearest data points of each class. The hyperplane is decided by finding the support vectors, which are the data points closest to the decision boundary. Now, let us understand the non-linear SVM, that is the SVM which can handle non-linearly separable data by using the kernel functions. The kernel function transforms the input data into a higher dimensional feature space, where the classes become separable by a hyperplane. The linear kernel used for linearly separable data, it corresponds to the standard dot product of the input variables, whereas the polynomial kernel allows the curved decision boundaries. It calculates the similarity between the data points using the polynomial functions. Radial basis function, that is RBF kernel, suitable for non-linearly separable data. It measures the similarity based on the Gaussian distribution of the distances between various points. Now, let us understand the SVM training, that is support vector machine training. So, SVM training involves finding the optimal hyperplane by solving the convex optimization problem. The goal here is to maximize the margin while minimizing the classification errors. Now, let us understand the soft margin SVM. The soft margin SVM allows for some misclassification errors by introducing a slack variable. It finds a balance between maximizing the margin and tolerating a certain degree of misclassification. Now, let us understand the support vector regression. SVM can also be used for solving the regression problem, that is regression tasks. Instead of finding a hyperplane, it now aims to find a regression line that fits the data while satisfying a certain tolerance level. Now, let us understand the SVM parameters C that controls the trade-offs between the maximizing margin and minimizing the classification errors in this soft margin, that is in the soft margin SVM. Gamma controls the influence of each training example in the RBF kernel. Now, let us understand the advantages of this SVM. SVM can handle high level or high dimensional data and works well with small to medium sized data sets as well. So, it is suitable for to handle high dimensional data, and it will also works well with small to medium sized data sets as well. It can handle non-linearity, or it can handle non-linearly separable data using the kernel function. SVM provides robustness to outliers and overfitting of the model. Now, let us understand the limitations of SVM. SVM can be computationally expensive, especially for large data sets. Selecting the appropriate kernel function and tuning the parameters can be a challenging task. Support vector machines are powerful algorithms which can be used for classification and as well as for regression tasks. Understanding the underlying principles, training process, different kernel functions can help in effectively applying the support vector machine to various real world problems. So, with this we come to the end of this session. Thank you for watching.